All right, chapter 9-7, we are going to be talking about linear and nonlinear functions. And really what we're going to do is we're going to take what we already know about linear equations, and we're going to use that to decide if either a graph, an equation, or a table. Those are all ways to deliver data, right? We're going to look at how to evaluate from a graph, from an equation, and from a table to determine whether or not our function is linear or nonlinear, okay? Sophia, would you mind flipping off the top light for me? Thank you. All right, so a couple of things first we want to talk about is some kind of terminology here. Linear means what? You guys remember? What's linear mean? Blake? Yeah, perfect. Straight line. So anytime we say something is linear, we're saying that it basically, when you graph it, it graphs as a straight line. What is the equation that we have used all along to go along with our linear equations? What's the equation for a straight line? It has it in there. Yes. There we go. Y equals mx plus b. Okay, that has been the equation that we have used over and over and over again anytime we're dealing with linear equations. And embedded in that is the m, which is our slope or our rise over run, right? Or our change in y over change in x. And then the b was our y-intercept. Okay. And then on the other side of the coin, if you will, we've got nonlinear. Well, that just simply means not a straight line. So pretty straightforward there. I said straightforward. All right, there you go. There's my little, that's my bad dad joke for the day. All right. When you're looking at a graph, it's very, very simple. Zero math needed. When you're looking at a graph to decide whether or not it's linear or nonlinear, you literally look at it and ask yourself, is it a straight line or is it not? And if it's not straight, it doesn't matter how it bends or curves. It's either straight or not straight. Okay. So for number one, without even, like I said, no math needed, we just know that that's nonlinear. It's not a straight line. And especially, you try to do some sort of, if you tried to figure out the change in y over change in x, it'd be different between these 2 points. It'd be way different than between this point and this point, right? It's not a constant change, rise over run. There's definitely some differences in the equation that causes it to bend. If you look at number two, it's a straight line, right? Now it's kind of it's one of our special cases. What are our two special cases? Do you guys remember? Horizontal line and a what? Vertical, yeah. Our horizontal and our vertical lines are our special cases. They don't really look like y equals mx plus b. You can, go ahead and expand the equation out, because this would be y equals, that's 1, 2, 3, 4. That'd be y equals -4. That doesn't look like y equals mx plus b, but does anybody remember what the slope of a horizontal line is with my little memory trick? Does it make a z or an n? Makes a z. So what's the slope? 0. So really we could write this y equals, the m would be 0, x minus 4. Well, what's 0 times x? It goes away and you're left with this. So when you have a special line, even though it doesn't look like y equals mx plus b, it really is. Okay. So, and you don't have to do all of this. I was just showing you that it really is y equals mx plus b. But the main thing to point out here is that it's just a straight line, right? So it is in fact linear. Yes.
So, so you said it's like a shape of a Z. If the slope would be 0, what would it be?
So if you have a vertical, whoop, that's a bad line. If you have a vertical line that goes up and down, if you think about what letter you could make with that, you could make an N. And so it's undefined is the memory trick. And then these, if you do this and this and this, your horizontal lines get a 0 slope. Yep. And again, that's just all a little bit of a review. You don't actually need any of that to answer linear or nonlinear. Determine whether or not each is linear and nonlinear. Now, the explain part that's here in the directions, I guess I should have touched on that a little bit. The explain part comes more when you get down to 4 to the rest of the problem. Honestly, 1 through 3, there's really not much to explain. It's linear because the line is straight. I mean, no, you do not need to write that out. So I'm okay if you don't explain on the graph ones. I'll show you here in a minute how to explain when we get to number 4. There is going to be a little bit of explanation there that you're going to give me. All right, how about number 3, linear or nonlinear? Yep, it's linear. And if we needed to, right, and we don't have to, but we're just going to do this because it's a good thing to practice. If we needed to, we could prove that we could write an equation in y equals mx plus b here, right? Because when you're writing an equation in mx plus b, we need an m and we need a b. What's the m of the line on number 3? The m is the slope. Blake? Almost. We go down 1, so it'd be -1/1. So our m, so y equals, our m would be -1. And then what's our b? Remembering that this is our y-intercept or our y-axis, and our b is where our line intercepts. So what's our b here? Yeah, +1. So pretty much very easily with a graph and a straight line, you can build an equation just by finding your m and your b. Because once you have an m and a b, you can write an equation in y equals mx plus b. All right, so now we're going to get down here. And when we get down to number 4, this is kind of where that explain comes in a little bit more. So I want you to give yourself a little note out to the side, okay, of how I want you to explain. Okay, though these are kind of my specific instructions on how I want you to do your homework. If it's linear, okay, if it is linear, then I want you to write the equation in y equals mx plus b. I want you to prove that you can, in fact, get it into y equals mx plus b by doing it. Do a little bit of algebra. Remember your wall, your equal signs, your wall. Move things around algebraically to keep the scale balanced is what I mean. When I say algebraically, that's just a really fancy word for keep your scale balanced. If you want it off the right, you need to move it to the left, subtract it from both sides or add it to both sides or do whatever you need to do. All right, that's if it's linear. If it's nonlinear, and this is just my specific instructions, okay? It doesn't really say this anywhere on your paper, which is why I want you to write this down. All I want you to do is obviously you're going to write the word nonlinear, but then I just want you to circle what makes it nonlinear or not linear. And that's all I need you to do as far as the quote explain, okay? So your answer is either going to be linear or nonlinear. You're going to write that under every problem. But as far as the explain part, the explanation of a linear is you getting it in y equals mx plus b and showing that it can be done. Your explanation of a nonlinear is just circle what it is that makes it nonlinear. Okay, what's the thing in it that trips you up? So let's look at number 4. All right, looking at number 4, we've got 5x minus y equals 15. And let's just remind ourselves here, our goal, if we're going to prove it can be linear, is to get it in mx plus b. Okay. So is there anything in number 4 that jumps out at you as very different, haven't seen it before, would make it seem like, I don't think I can get that in y equals mx plus b? Or do you look at that and think, yeah, with a couple moves, I can get it in linear? What do you guys think? Think we can do linear? Okay, I think we can do this. All right, so let's look at our equal sign. I always do this. It's just a little bit of a memory, kind of a mind focus thing. Let's get our wall up there. And remember the goal when I'm getting things in y equals mx plus b, my goal is to get y by itself. So what would I move first to get y by itself? Yeah, let's get that 5x, because notice in the actual equation up top, my mx, or my value that has an x with it, is on the right side of the equation. So let's move that first. So it's positive 5x, so I'm going to minus 5x. If I do it to one side, I do it to the other. And notice I don't write it right under the 15. because I cannot combine something with an X and something without. So on the left, I'm left with negative Y. My wall still stays where my equal sign is. And on the right, I now have a 15 and a negative 5X. Which one am I going to write first? Can't combine them. So I'm just going to list them both. Which one do I list first? If I want it in MX plus B, I want the one with the X first. Yeah, I want that negative 5X first because I want it in MX plus B. And so I always write my X value first. And then it's a plus 15, so I'm going to write plus 15. Not quite there yet. I need to get that negative off there. And it's attached. It's really a -1 attached with multiplication. So I'm going to divide a -1, but if I do it to 1, I do it to all. Think distribution there. If I distribute candy to 1, right, I have to distribute candy to everybody. So that gets me Y equals negative and a negative goes positive, and a positive 15 divided by a -1 goes negative. So I've proven I can get it in Y equals MX plus B. So then I finish my answer by writing the word linear. And I circle both because both of them are part of my answer. Because first I determined that it's possible. I wrote the word linear, and my explanation is just the work that it took to get it in MX plus B. Okay. All right, so let's look at number 5. Is there anything in number 5 that jumps out at you as different, something we haven't really dealt with before, something that would prevent this from being just plain old Y equals MX plus B? What do you guys think? Yeah, that X squared, that's a problem. So it's nonlinear. And we will actually spend time this week. The squared is going to give you a quadratic graph. We're going to spend time tomorrow on quadratics. So you'll know more about this as we get into the week. But if you have an X or a Y that is squared, cubed to the 4, I don't care to any power whatsoever, that is automatically going to exclude it from being a linear equation. Because you just need a plain old Y and a plain old X. Okay. All right. How about number 6? Anything jump out at you weird about number 6? Any weird exponents? Anything that you're not familiar with? Blake? Well, the 3, but just having a 3 in an equation, does that exclude it from Y equals MX plus B? Is it in the right spot? No. But can we start moving things around and get it in Y equals MX plus B without there being a problem? Because if you think about it, if we had tried with number 5, and you guys don't have to put this in your notes, but if we had tried to move this around, we could have subtracted the 12X to the other side. And that would have given me 3Y equals negative 12X squared plus 0. I could divide by 3, right? I can do that. And I get Y equals negative 4X squared plus 0. No matter how much I move algebra around, I'm not going to get rid of that problem square, right? So that's what excluded that one from working. On this one, I still might need to move things around, but is there anything, even after I get things moved around, that you see would trip us up? Don't have a square in there, don't have a cube in there, don't have any weird. So let's try to start moving things around and just see if we can do a little bit of algebra. If I'm trying to get in Y equals MX plus B, there's a couple of different things here. What's one of the first things I would move? Colton? What do you think? Okay, it's a positive, so I'm going to subtract. And I'm going to put it right under the 0 because I can combine numbers here. And that gives me 5Y minus X, and then my equal sign stays there, and 0 minus 3 is negative 3. All right. What else? What's another thing I'd move? Damien, what do you think? Now keep in mind, what's my goal? Yeah, let's get this. It's a negative, so I'm going to do positive. And now notice I don't write it right underneath that negative 3 because I can't combine those. One has an X and one doesn't. So I'm not going to combine those. So now over on this side, I'm just left with 5Y. What am I going to write first on the right? The negative 3 or the positive X? Positive X and then the negative 3. So X minus 3. Now what? Autumn? Yeah. Now remember, all of them get it. Distribute. If I'm going to divide or multiply, you always think distribute, and everybody gets it. So when I'm done, I get Y equals. Now, I want to write this in mx plus b. So I'm not going to leave it x over 5. How am I going to split this out and really write it in true mx plus b form so that I have an m, an x, and a b? Yeah. Yeah, you just have to remember that this is really a 1. There's always a 1 behind a variable, always. So if I want to write this as an m and then an x, I want that x and that 5 separated out. I don't want them together. And so I'm going to write this as 1/5 x. It means the same thing, but this is a little bit cleaner for mx plus b. And then it's okay for your b to be a fraction here. Thankfully, we're not graphing this. So who cares that it's a fraction? So because we were able to get it into y equals mx plus b, nothing's out of shape, nothing's out of form, nothing is squared here. Is this one linear? What do you guys think? Yes. So we're going to write linear. And again, I'm going to circle my y equals mx plus b and my word linear as my answer because one is the answer and one is the explanation. Okay. And we're going to come back to this in a minute. So I just want to go over this kind of really quickly here. When you have an x over 5, that can really be written, okay, because a fraction is just 2 fractions multiplied by each other. If I want to make this 2 fractions multiplied by each other, the x is on top, so I'm going to split it out and give it its own fraction, and that would be over 1. And then I'm going to split the 5 out by itself. It's on the bottom, so then I would put a 1 in the top. Do those 2 things equal each other? If I remultiply, x times 1 is x and 1 times 5 is 5. So that is just taking a single fraction and breaking it into 2 individual fractions. There's no harm in that, okay? So my x just would be an x and my 1/5 would be a 1/5, okay? All right, we're gonna come back to that thought in a minute. So I'll show you why I kind of pointed that out. All right, how about number 7? Does anything right off the bat jump out at you as a problem? Yeah, you can't have x under a square root sign. That's going to totally make your graph squiggle and wiggle. That is not going to be a straight line. So that's going to be non-linear. And it was really because it was over the x, it's over the y, if it's anything like that. Because I want to show you this, and I added this example here. Just because there's a square root in there doesn't automatically, boom, non-linear. Why? Why would the one I have right here, why would this one, why would that square root not automatically exclude it from being linear? Eli? Yeah, just if you can reduce it, and it looks like that, that's a linear equation. So don't let a square root just immediately, an x squared, that's an immediate. An x cubed, that's an immediate. You don't even have to think about it. If it's a square root, go ahead and see if it's something that you can figure out, okay? If it's not something like the square root of 64 or the square root of 49 or something like that, that you can just reduce and it still fits really nice in y equals mx plus b, okay? All right, how about number 8? This is where I said I'm gonna come back to this idea of splitting a fraction. So before I answer this one, I'm gonna split this fraction. So I'm gonna go y equals, I'm just gonna rewrite this with that fraction split apart. So I'm going to give myself 2 fraction lines. And now I'm going to pull this 8 and this x, kind of slide them apart and make them 2 separate fractions. The 8's on top. I'm going to keep it on top. I'm going to go ahead and put it over a 1. The x is on bottom. So I'm going to leave it on bottom and put a 1 over it. So now I have rewritten this equation. I haven't changed the value. I've just rewritten the fraction pulled apart. So I've got, even if you want to clean it up a little bit, you've got y equals 8, 1 over x. And if you wanted to put a b on there because you want a plus b, you could put a plus 0. Am I in y equals mx plus b? What do you think? Do you see a problem or a difference in what we're used to seeing? Have we ever had the x in the bottom of a fraction? There's the problem. Y equals mx plus b. The x has to be a whole x. This is just a fraction of an x, which would change your graph to not linear. Yes. No, you wouldn't actually do any math here. So what I'm just showing you that when you split that fraction apart, because the x is in the bottom of the fraction, you're no longer y equals mx plus b. Your y equals something, but your x is now a fraction. And with your x as a fraction, it's going to completely change your graph to nonlinear. Now, I do want to tell you this. If you remember the rule of an x on bottom is a problem, you can just simply circle that and say nonlinear. Okay, you do not have to do this work right here. I just did this to show you why, but you do not have to include this in your explanation. If you recognize that an x in the bottom of the fraction is a problem, you're fine. Okay. I just wanted you to show the difference between here, the x was in the top and that was okay. Here, the x is in the bottom, that is not okay. Okay, x in the bottom makes it nonlinear. All right, how about number 9? Right off the bat, what do you see that's a problem? Yep, the x squared, that's a problem. It's nonlinear. How about this one? Y equals 2x. Would you guys say that's linear or nonlinear? Linear, because really it's there, but it's not there. It's in y equals mx plus b. Okay. Your b is just a 0, which means your graph would go right through the origin. So, all right. How do you do it when it's in a table? Well, you got to test the rate of change. See if it's constant or not. How do my x's change? I go up 1, I go up 1, I go up 1. This is showing your work or explaining. Okay. How do my y's change? I go down or minus 0.2 here. If you need to in your calculator, 1 minus 0.8 is -2. Negative or 0.8 minus 0.6, I go down 0.2 again. I'm going lower. And here I go down 0.2 again. Is my change in y or my change in x constant the whole time? Then it's linear. The explanation just comes in you showing your rate of change on both sides of the table. Okay. Okay, let's check our rate of change on number 11. First, let's check our x. Now, 44 to 48 is an up move, right? We're going bigger numbers. So +4, +4 again, +4 again. Okay, I'm good there. Let's check how our y changes. I go +2.5. What's my rate? What's my change from 2.5 to 5.0? +2.5. How about to 7.5? +2.5. Is that a constant rate of change? That's a rise over run that never changes, right? So it's linear. Because, and if you need to remind yourself, it's because it's a constant rate of change. Now, the key says you have to actually write those words out. I don't care about that as long as you have this right here that shows me you know why you picked linear, because your rate of change was the same. Okay. And then on number 12, let's check our change in y. We go up 3, up 3, up 3. We're good there, right? Yeah. So 1 down to -2 is a -3 move. Down 3 more, we're still doing good. But then what happens? It goes no. We lost our constant rate of change. So this one would be nonlinear. And that's it. So at the top, really no explanation needed. Just write linear or nonlinear. It's a graph. Look at it and tell me, you know, is it a line or not? In the middle, I've got the instructions there. If it's linear, get it in y equals mx plus b. If something is the no-go or the stopper, just circle the stopper. And then at the bottom, show me the rate of change on the x's and the y's. If it's constant, it's linear. If it's not constant, then it is not. All right, on your homework, there's only 15 problems, and over half or about half of them are the real simple, easy ones where there's no work needed. So I do want you to do them all. And for those of you at home, email me if you have any questions.